Millions of hydrocarbon compounds exist in nature. These compounds may be classified as either saturated hydrocarbon compounds or unsaturated hydrocarbon compounds. Saturated hydrocarbon compounds will fit the general formula CnH2n plus 2. There are two classes of unsaturated hydrocarbon compounds: the alkenes, which fit the general formula CnH2n, and the alkynes, which fit the general formula CnH2n minus 2. Hi, this is Mr. B. In this video, I'll explain how to name and identify isomers of alkyne compounds. The simplest alkyne compound contains 2 carbon atoms. The chemical formula for this compound is C2H2, and the name of the compound is ethyne. Remember, when naming any hydrocarbon compound, use the correct Greek prefix, and the ending of the name will identify the class of compound. C2H2 will fit the general formula of a class of unsaturated hydrocarbon compound known as the alkynes, where N is equal to 2 and H is equal to 2 times 2, or 4 minus 2, which is 2. The name of this compound will be ethyne. To write the structural formula for ethyne, connect 2 carbon atoms via a triple bond. The remaining bond for each carbon atom will be connected to an H. In order for carbons to form a triple bond, the atoms must undergo sp hybridization. This means that the bond angles for the atoms involved in the triple bond will always be 180 degrees. The alkyne compound containing 5 carbon atoms is known as pentyne. The chemical formula for pentyne will be C5H8. The structural formula for the compound will contain 5 carbon atoms, where 2 of the carbons are connected via a triple bond. When naming alkyne compounds containing more than 3 carbon atoms, the position of the triple bond must be indicated. In the first example, the triple bond is located behind the terminal carbon on the left. The name of this compound will be 1-pentyne. When naming any hydrocarbon compound containing a double or a triple bond, the bond position must be given the lowest possible value. So the name of this compound would not be 1,2,3,4-pentyne. The name of the compound is 1-pentyne. If the triple bond is located behind the second carbon from the terminal carbon on the left, 1,2, then the name of this compound will be 2-pentyne, not 1,2,3-pentyne. And of course, if the triple bond is located behind the 1,2,3 third carbon on the left, then the name of this compound is not 1,2,3-pentyne. The name of this compound will be 1,2-pentyne. In this example, numbering the carbons in the parent chain begins on the right. Remember, when assigning positions to either a double or a triple bond, the location of that bond must be given the lowest possible position or number. So this compound will not be 1,2,3-pentyne, it will be 1,2-pentyne. Another structural formula for pentyne would be a compound that contains 1, 2, 3, 4 carbon atoms in the parent chain. So the name of this compound will be butane. When naming this compound, remember, the triple bond must be given the lowest possible position. So this compound would be called 1-butane. An alkyl group is connected to the third carbon from the terminal carbon on the left. The location of the triple bond will always be given priority in terms of numbering the carbon atom. So this compound contains a methyl group bonded to carbon 1, 2, 3. The name of this compound will be 1, 2, 3 methyl 1 butyne, not 1, 2 methyl 3 butyne. Okay, now let's name this compound in which there appears to be 2 methyl groups connected to carbon 3. The name of this compound would be 3 methyl 1 butyne. When identifying the parent chain of any hydrocarbon compound, locate the longest continuous chain of carbons. In this example, the longest chain is obviously 1, 2, 3, 4, or it could be 1, 2, 3, 4. The parent chain need not always be written horizontally. Sometimes the chain will be written with an angle. So when naming this compound, simply identify the longest continuous carbon chain, 1, 2, 3, 4, or 1, 2, 3, 4. In any case, the compound will have a methyl group connected to carbon 3 and a triple bond after the terminal carbon on the left. So the name of this compound is exactly the same as the name of this compound, 3 methyl 1 pentyne. And incidentally, 3 methyl 1 butyne is the only structural isomer of 1 pentyne.